Hello and welcome back to this exciting lecture into the world of programming with generative AI. We're thrilled to have you here at the AI Academy, where we don't just teach code, we teach how to think, solve, and innovate with code. What you'll learn in this lecture. By the end of this session, you'll be able to see the programming not just as a technical skill, but as a powerful tool for solving real-world problems. Distinguish between algorithmic problems, those that follow clear rules, and data-centric problems, those that require learning from patterns. Understand why generative AI is such a game-changer in programming, and how it helps with both logic-driven and pattern-driven tasks. Most importantly, you'll be ready to move forward in this course with the right mindset, one that's focused on purpose, not just syntax. Let's start by rethinking what programming really means. You might think programmers just write lines of code all day. But that's not the real story. Programming isn't just about typing code, it's about solving problems using code. Here's a simple analogy. Think of a swimmer. A swimmer doesn't swim just for the sake of moving their arms and legs in water. They swim to reach a destination. In the same way, a programmer doesn't write code just for the fun of writing syntax. They write code to achieve something. They may be building a website, or analyze data, or to automate a boring task. And once we're clear on this, we can better understand where generative AI fits in, because it's also a tool designed to solve problems, just in a more powerful and flexible way. So now that we know programming is all about solving problems, let's dig a little deeper. When you write code, you're not doing it just to show off your Python or Java skills. You're doing it for a reason, to solve a specific problem. This is what we mean by purpose-driven programming. For example, imagine someone writes 100 lines of beautiful code that doesn't actually do anything useful. Sure, it might look nice, but what's the point? On the other hand, someone else might write just 10 lines of simple code that solves a real-world issue, like calculating discounts on an e-commerce site or helping doctors track patient reports. That's purposeful programming, and that's what really matters. Here's the key distinction. Code that solves a problem has real value. Code that merely exists is just code. It might work, but it doesn't really do anything meaningful. So as a programmer, or someone learning to program, your first instinct should be, what problem am I solving? Because understanding the problem is more important than memorizing the syntax. And guess what? This mindset is also what makes generative AI so powerful. It helps us move faster from idea to solution. Now, here's something important to understand. Not every problem is meant to be solved with programming alone. That might sound surprising, but it's true. Let's take two examples to see what we mean. Example 1, an astronomy problem. Suppose scientists are asking, is there a planet beyond Neptune? This is a big, complex question that falls under astronomy. Now, programming can help. It can power the software used in telescopes or simulate planetary motion, but the core of the question is still scientific. Programming is supportive, not central. A number theory problem. Now think of this question. Is this number prime? This is a perfect problem for programming. Why? Because you can break it down into clear steps. Check if the number is divisible by anything other than 1 and itself. This kind of structured, rule-based problem is what computers are great at. They can run those checks quickly and accurately, far faster than we ever could by hand. So the big takeaway here is, programming shines when the problem is logical, structured, and can be broken down into clear steps. For more abstract or scientific problems, programming still helps, but it plays more of a supporting role. We will now look into how computers handle algorithmic tasks like prime checking. Let's take a classic example of a problem that programming is great at solving, checking if a number is prime. So, what's the basic idea? A prime number is a number that's only divisible by 1 and itself. To check if a number n is prime, the simple algorithm is, try dividing number n by every number from 2 up to n, 1. If none of them divide it evenly, it's prime. Otherwise, it's not. That's it. But the problem is that if the number n is something like 10 million, doing all those checks manually would be painfully slow, maybe even impossible. That's where computers come in. They're built for this kind of thing, such as repetitive tasks and exhaustive checking. They don't get bored or tired, they just keep running. But it doesn't stop there. While this basic method works, it's not very efficient, especially for really large numbers. That's why researchers keep improving algorithms. So, even when a solution exists, algorithmic innovation can make a huge difference in speed, performance, and scalability. So, this example shows why programming is so powerful for well-structured problems, and why efficiency and innovation in algorithms really matter. Next, we'll shift our gears and look at problems that don't fit so neatly into an algorithm, but the kind of problem that need a totally different approach. Until now, we've talked about problems that have clear, step-by-step solutions. These are what we call algorithmic problems. They're perfect for traditional programming because we know exactly what steps the computer should follow. But not all problems work like that. Now let's look at a different kind of question. Is this a cat? It sounds simple, right? Humans can recognize a cat instantly, whether it's sitting, jumping, or half hidden under a table. But try to write an algorithm for that. How would you explain what makes a cat a cat? Based on observations: look. 2 ears? 4 legs? A tail? What about a blurry photo or a weird angle? It turns out, this problem doesn't have a clear list of instructions. That's where data-centric programming comes in. Instead of telling the computer how to recognize a cat, we give it lots of examples, thousands or even millions of images of cats, and let it learn the pattern on its own. This is the foundation of deep learning, a type of AI that doesn't rely on handwritten rules, but on learning from data. So, here's the big shift. In the algorithmic problems, we write the rules. And in the data-centric problems, the computer learns the rules from examples. This shift has been a game changer. It's why AI can now recognize faces, translate languages, and even generate realistic art. And that's why generative AI is so powerful. It can handle both sides, like structured problems with clear logic, messy, real-world problems that need pattern recognition. Now that we understand both sides, such as algorithmic problem-solving and data-centric learning, let's talk about what makes generative AI so exciting. The magic of Gen AI is that it brings both worlds together. Think about it this way, that on one hand, Gen AI can follow logical steps like solving a math problem or writing a sorting algorithm. And on the other hand, it can also handle tasks that don't have clear rules, like understanding natural language or generating an image from text. Because it blends algorithmic logic and data-driven learning together, Gen AI is perfect for the kinds of challenges we see in modern programming. Here are just a few things Gen AI can do, such as generate code from simple natural language instructions, help and debug code by explaining errors or offering fixes, translate code between different programming languages, even assist with creative tasks like writing stories, designing UI components, or composing music. In short, generative AI extends help to what programmers can do, not by replacing them, but by amplifying their abilities. It becomes a kind of intelligent partner that helps us solve problems faster, more creatively, and at a much larger scale. And that's exactly what this course is all about, helping you understand both the traditional programming mindset and the new world of Gen AI-powered tools and techniques. Now that you understand the why behind programming and how generative AI fits into the picture, let's talk about what's coming next. This course is designed to give you a strong foundation in both key areas of modern programming. First, we'll dive into algorithmic programming. This is the traditional side of coding, learning how to break problems down into clear steps, write logic using loops, conditions, and functions, build efficient solutions using structured thinking. Then, we'll shift into data-centric programming. This is where things get even more exciting. You'll learn how to work with data, how machine learning models learn patterns, and how to use AI tools to solve complex, real-world problems. By the end of the course, you'll not only be comfortable writing your own code, you'll also understand how to collaborate with generative AI to build smarter, faster, and more creative solutions. So, whether your goal is to become a better programmer, dive into machine learning, or explore AI-driven development. If you liked the lecture, don't forget to like, share, subscribe, and comment below. Follow us for more on the AI Academy.